Hello, my name is Tony Heil with the ALS United Mid-Atlantic, and I am here with our regular Goals podcast. If you've listened to some recent episodes, you know that we've spoken with people from a variety of perspectives when it comes to ALS. From people living with ALS, to researchers, caregivers, advocates, volunteers, board members. It takes everyone together to make a difference in supporting ALS care and research and advocacy. For you, if you're interested in joining our mission, please go to www.alsmidatlantic.org or follow us on social media at ALS Mid-Atlantic. Our organization supports many multidisciplinary treatment centers in our region in Pennsylvania, New Jersey, and Delaware. Each year we support over 1,200 people with ALS in our area. And we support now we're involved with 10 different ALS treatment centers in our region. And that includes one that we've been working with for care and research for 30 years now. And that is at Penn State Health Hershey Medical Center. It is a nationally recognized center for research, well respected for all forms of ALS research and research into other diseases as well, as you've heard from our recent talk with Dr. Zarnescu. And today we're going to be talking with two doctors who have expertise in brain-computer interface and some of the technology that is very exciting right now that shows a lot of promise for ALS. Dr. Andrew Geronimo and Dr. James Grogan. For just a brief update, Dr. Geronimo was given the Flame of Hope in 2020 from the ALS United Mid-Atlantic for his work in advancing brain-computer interface and using telehealth and other tools to support communication. Dr. Grogan did have a fellowship at the University of Virginia Health System a few years ago. I hope I have that right, Dr. Grogan. And he also is a strong advocate for ALS research, real interest in neuromuscular research, and has worked on BCI and telemedicine and other ways to connect ALS patients to the care and research that they need to advance treatments. With that introduction in mind, thank you, Dr. Geronimo and Dr. Grogan, for speaking today. So I'll ask you both, we'll go alphabetically, so you guys can change your mind, I guess. What got you interested in this field of research with brain-computer interface? Because I know you've both been working on it for a number of years, and there have been so many advances since then. So what got you interested in the first place?
Well, I just heard about it for the first time, and I thought, well, I want to be involved with that because it just sounds cool. And I did my graduate school training working on these systems, and that was back in 2010 up to 2015. And I've continued working with them ever since. And during that time, I started working with the ALS population to use these systems, these brain-controlled systems, for communication purposes. So I've been doing this for a little while now, and it's been really exciting to see where the field has taken us and where it's going to continue to go in the future.
And in part to echo that, I just think it's cool. Seeing a lot of sci-fi movies as a kid, TV shows, and seeing what the future could hold for us, and then realizing that a lot of the needs that we have are very real, but also some of the solutions may be very futuristic seeming, but not that far away. With ALS, it's a devastating disease, and no matter where it starts, in a leg, an arm, or a throat, it affects people in so many ways. And I think communication really is one of the biggest damages someone can accrue. It's one of the most devastating impairments they can have because it's who we are. It's our relationships with people. It's our ability to communicate our needs with people. I think finding ways to help with that, finding ways to reconnect people is one of the best things that we can do. And sometimes it's as simple as writing things down or using voice commands to control a computer. But now that we're finding more and more nuanced and advanced ways to do that, even the most impaired patients with ALS can find ways to communicate and at least reclaim some of what was taken from them. I think that's really cool, and it's amazing what the future is going to hold for us.
It reminds me of watching TV shows like The Pit and ER on television, because you'll see a lot of doctors who really want to be involved in a certain surgery or a certain procedure for the reason you guys both said. It's cool and it's an education for them. They want to be part of something interesting in healthcare, so they'll learn from it and they can do something later. I guess that's pretty common in your field that, yeah, you care about healthcare, you care about your ALS patients, but also you like being involved in cool science.
Yeah, I came from a non-medical route. I came through the engineering field into neuroscience and brain-computer interfaces, but I totally agree. I thought I wanted to do biomechanics work and dealing with the human body, but not quite on the brain end, and I kind of gravitated towards the neuroscience aspect of it.
And I was just at our research center at the Jefferson Weinberg Center in Philadelphia, Thomas Jefferson University, and I was meeting some of the researchers there who had come from other fields, and then they came to work on ALS. And we talked about how important it was that we recruit and retain people who came from those other fields. Because you could go and work at just an engineering place, you could work in some other field with that kind of expertise. How important is it through funding through NIH and other support from government and nonprofits that we recruit people and retain people like yourselves to stay focused on ALS when you could be doing something else?
Yeah, I think the involvement of multiple specialties is going to be what eventually solves ALS. Dr. Simmons, who is the director of the ALS clinic here at the Hershey Medical Center, kind of recognized when I was starting in the program that this was maybe a good person to keep around, someone who thought a little bit differently and had different skill sets than the great neurologists that were here and continue to be here. But people like Dr. Zarnescu, who's taking a different approach to the disease, and other people who are looking at different technologies, they're all combining their different skills to attack this disease from multiple angles. And I'm hoping we make an impact on the quality of life, not maybe solving the illness, not treating the disease, but improving quality of life through these communication interfaces.
And I think from the physician side, a lot of what I do is in education, and I think a big part of this isn't just retaining talent, but also recruiting into neurology in the first place, which historically neurology is, there aren't enough of us. There's a gap, there's a need. And then I think within neuromuscular and ALS in particular, there's this stigma that really keeps people out of it. Neurology for a long time had a diagnose and adios reputation. And I think people are still clinging to that when they need to see how much good that you can do. And part of that is with technologies like this, but just in the ALS clinic, students are always surprised how much, I don't say joy, but how much positivity, how much gratitude, how much of a connection we build. And even for our incurable diseases right now, there's still a lot of hope and there's still so much that you can do. So I think cultivating that spirit in our trainees is also so helpful because it makes sure that the next generation is going to come along as well. And some of those will be doing neuromuscular, some of those will be doing ALS and neuropalliative and serving these populations that historically have been really underserved.
Dr. Grogan, I know that you have education and experience in multiple places in the country, Indiana, Virginia, and you came to Penn State Health Hershey Medical Center. Dr. Simmons has really built a great reputation for the center nationally. What was it like seeing that and coming to Penn State Health Hershey Medical Center? What is that reputation like that brings in leaders like yourself and Dr. Zarnescu and obviously Dr. Geronimo to work at a place like that to expand research and care?
Thank you for including me in the category with the other two. It's 7 years ago, I couldn't have planted Hershey on a map. I met Dr. Simmons at a conference while I was still a fellow, and he introduced himself, talked about his philosophy, talked about his thoughts on patient care and the big picture as well as individual cases, and it was inspiring. So I think a lot of it is through Dr. Simmons' work. I have worked at 4 ALS clinics, and each one of them, through different parts of my training, but each one of them has had incredible skills and dedicated personnel that really looked after patients in a great way. I think that the ALS clinic is one of the reasons I came to Hershey, one of the reasons I stayed at Hershey, in part because the care is so comprehensive, the resources are so great for what we can provide. So I think the longer I've done this, the more I realize how strong the reputation is from the research perspective for an area our size. And the fact that we have a center like this in a fairly rural area, we're not in Philadelphia, we're not in New York, we're not in Pitt, but to have something like this nestled away in central PA really it's a gem. And I think that's one of the many reasons that I've stuck around.
And even though you are in central Pennsylvania, I know a number of people who come from over 100 miles away
Oh,
to
yeah.
see Dr. Simmons and to see your researchers. Even people that go to other ALS treatment centers and really like them, they come to you guys to participate in research. And I think that is a testament to, your reputation and the work you do.
And a lot of them end up staying as our clinic patients as well. Coming in from New York, Maryland, West Virginia, Delaware. And it's very humbling to have people, sometimes at great personal expense, make the schlep over here to get their care and trust us with that.
So let's talk about BCI because it is very exciting. There's so much happening in this field. What is kind of driving advances in brain computer interface now?
People are very keen on some recent results that have come out in academia that have shown we can do far greater things than we ever, in the last 10 years thought possible, such as decoding speech directly from brain activity. And the other thing is that there's been a lot more commercial interest in the last few years. We've seen a number of startups that have gone to clinical trials of brain computer interfaces, deploying them in different patient populations. Some of them being used for just environmental control. Can they use these devices to control smart objects in the home? Others using it for communication. Can they use these devices to control a communication system? But I think those are the two main things that we're getting more comfortable with being able to record from inside the brain, and more companies are being able to do this now and have developed the infrastructure to be able to conduct these clinical trials, because that's how they're going to eventually get approved for use in ALS and other disorders like spinal cord injury and brainstem stroke.
So let me ask this simple question. How does that work? Like I've seen you put the cap on someone's head. I've seen things about attaching to things inside your brain. My grandmother had deep brain stimulation, which is different, but still, like, I know it worked. But when you're talking about communicating with your brain, one, not just how does it work, but how did you figure out how to figure out that it could work?
So to answer the last question, a lot of neuroscience research, basic research funded by the NIH and other organizations such as yourselves, funded what we know about the brain right now. And because of that, we're able to stick electrodes in the correct places, knowing that the neurons representing these actions, these intents, are represented there. And we can read the action potentials of neurons and populations of neurons to be able to translate that. In ALS, it's the motor neurons that are affected. Motor neurons prevent the signal going from the brain out to the muscles. So when that connection is lost, we need to have a direct connection from the neurons in the brain out to some sort of effector, whether that's a stimulator on your arm, maybe for someone with spinal cord injury, or a robotic device, or a communication device, such as a computer with speech generation. So I think the main thing that's happened in the last few years is our ability to actually read very closely from individual neural populations in the brain. And to bring it back to deep brain stimulation, I do like to take a step back a little and clarify these things. These are all brain interfacing devices, but we don't call DBS a brain computer interface just because brain computer interfaces are just by definition designed to convey some intent of the user. Whereas a deep brain stimulator is stimulating the brain in order to reduce tremor in Parkinson's disease and other tremor disorders. I don't know if that's clear at all.
It's clear to me because I've seen in both. My grandmother had it, and it went for her tremors for Parkinson's went away during the surgery, which was, I wasn't there for it, but my mom, I remember being amazed. But then you see that, and then you see the work that you guys are doing with communication and with actual BCI, and it's just amazing how sometimes it can be like a light switch, and you're getting things so quickly. When you're looking at these BCI research studies, when we're testing your devices, how do you know it's working? Because I've seen some of the work you've done with one of my friends, Dave Eide, I think you may have worked with years ago. And he was great. He was always eager to participate. How do you know that a communication device through BCI is actually working?
Well, you're recording from the brain, right? So in my case, I use EEG. I use scalp electrodes to record from the brain. And if I remembered correctly, Dave Eide was using a system where he would imagine the movement of his hands. So imagine squeezing his left hand or imagine squeezing his right hand, and he would control a cursor moving back and forth on the screen by thinking about it. So what do I want to? I want to make sure he's not shooting his eyes to the left and right to make that look like a brain signal. I want to make sure he's not actually squeezing his muscles to make sure he's not controlling it using his muscle activity. So I just want to make what I look for in my experiments is I see that it's actually specific changes in the brain activity that are controlling this movement left and right. And if you want to know the details, it's changes in these specific frequency bands, these motor rhythms that occur over the motor cortex, that we look for in this specific interface. Of the newer interfaces, the ones that decode speech, they're looking for much of the same, except they're looking in the speech motor area. They're looking to see certain neuron populations that fire when you're doing these different phonemes or different syllables that you're either speaking or imagining speaking. So it comes down to these oscillations that we're looking for in the brain or the individual spiking of neurons from an expected area that we are, anticipate them to come from.
And Dr. Grogan, when I talking about Dave Eide, that was a decade ago that I remember him participating in that, more than a decade ago. So what are some of the advances that you're excited that you're participating in now with BCI and this technology?
Yeah, and I think it's in part BCI and in part non, like more of the indirect, like other ways that we interface with technology too. So with BCI, one of the cool things is like Dr. Geronimo was saying, the resolution that we can look at down to the gyral, like to the individual gyros or even subgyral level. Even when I was a resident, a little longer ago than I like to think about, there were presentations from one of the UCSF labs about language and interpreting language from the direct electrode contact, and that was almost a decade ago. So it's come so far since then, as we've seen in recent presentations. So I think the advances in the granularity of the information we can get really is exciting. Also, how invasive it is. You know, a lot of these devices are pretty honking huge. You can't really implant them or embed them fully. So how do you accommodate for that? How do you account for that? And there's miniaturization, which is still on the way, or there's other ways of doing it, like with some of the stentroids to, instead of having a direct contact with the cortex, they thread it up through a vein into the superior sagittal sinus, and then it picks up electrical readings on either side of the brain. So it's less invasive. You don't have to cut a hole in someone's head, though I don't know what the resolution is compared to other forms of BCI. So I think just the fact that people are so creative in finding both higher fidelity ways of measuring output, but also finding less invasive ways, and then hopefully in the future finding ways to marry those two priorities. I think that's what gets me really excited thinking about it. I think the other thing too is just looking at non-implantable ways of doing it. So one of our studies is looking at augmented reality as a communication tool in patients with ALS, using headsets, kind of like a VR headset, like an Oculus Rift. In this case, we're using an Apple Vision Pro, which can look at eye movements, do a eye tracking or gaze control type selection while still ensuring that people have their environments around them. It captures and recreates the environment and then just floats their text window, their keyboard, things like that. So they can still engage, still maintain contact and eye contact while being able to access whatever their phone or computer could do using only their eyes.
Yeah, this is a technology that did not exist 5 years ago. Currently, all the eye trackers that are used by people in our clinic are made by one company, and they are mounted on a computer, or mounted on their wheelchair, or they sit on the desk in front of them, and they use eye tracking that shoots it shoots an infrared signal to their retinas, which is reflected off, and it can detect where you're looking on this computer screen. And for anyone who's used one of these devices, you know that they're a lifesaver, but they come with significant limitations, like being unable to use them in outdoors, or needing to recalibrate all the time. So we really do think this new technology, where you're wearing a set of glasses or goggles, and it's reading and it's tracking your eyes from those glasses. We think this might be a big opportunity to advance the field of eye tracking to make it more easier and more versatile for individuals with ALS.
I know Elisa Brownlee, who you may both know here. She's been working with assistive technology for over 25 years, and the most basic form for her is using a letterboard. So with that, is that like using a letterboard where you're looking at different maybe letters or some key phrases that are on a screen or on a wall, and you're using your mind to deliver a message by looking at that instead of someone asking questions?
Yeah, so that goes into a little bit more complicated, but for letterboards, you can do them a number of ways. People can point to a letterboard if they're unable to speak. A caregiver can point to a letterboard and they can indicate somehow that that's the one that they're looking at, nodding, gesturing, blinking. But and this gets to kind of the device that Stephen Hawking used for a large period of his life, including towards the end of life, which is a scanning interface, a device that scans between multiple selections. And he used a cheek interface to be able to indicate which ones he wanted to select. Right when it landed on the one he wanted to select, he would twitch his cheek. So there are a number of different ways you can use simple things like a letterboard in non-simple ways, like Stephen Hawking did. But yes, I think the much of this interface of eye tracking is based on that idea that you're focusing your attention on an object in your screen. With the eye tracking, it's intuitive. You're looking at it, you're holding your gaze there until it selects, and then you're moving on to the next thing.
So let me ask a deeper question about language, because I love learning about linguistics. When I was in college, read Steven Pinker and some others, and I, what does it teach you about actual language and linguistics when you see this technology working in someone's brain? Because you have different languages, you have different just ways of people talking with dialects, and you're maybe interpreting that through technology. Do you learn a lot through how people communicate, maybe some just essential words now that you're using technology in their brain?
These are great questions, Tony. I think these are something when we figure out, when we get a better grasp on how to use these devices in more people, this will be a big thing that we're asking. But honestly, this is a question way beyond my pay grade. I can point you to certain people who are in the School of Communication Sciences who might be able to, who think about this a lot. But the way that we get around this currently is we add extra pieces of technology in our interfaces. People save phrases and have ways of speaking that they can just save to the device. And this is often used by people who use different types of high tech communication devices. And it can be a big time saver. And also, it keeps a lot of their personality that they, in addition to hearing their voice, you hear the way of speaking that they would convey.
And I will say, from a language perspective, we see a lot of what we're seeing with these devices is what we're already seeing with cell phones, with computers. The shorthand that people use, the emojis or emoticons that people use, even predictive typing and texting. So I think a lot of what we're looking for with these more advanced technologies, we're seeing in day-to-day use for everybody. I'm trying to think what else there is.
Since you brought up predictive typing, I think an essential piece of this technology and BCI is AI, and specifically word and sentence prediction using large language models. And this is something you see in all the new BCI applications. People aren't typing uh, uh, 80 characters a minute, right? They're typing a few, and then it's using word prediction to kind of assume what the best way to fill out that sentence would be, and then the user is giving the indication, yes, that's correct, or no, I want to keep typing. So I think the revolution in speech prediction and large language models specifically driving a lot of this innovation that we're seeing and some of the really interesting results that we're seeing in the BCI field.
It's interesting. I was in Washington, D.C., meeting with Senator Chris Coons and our mutual friend Craig, who has ALS. And he was using his eye gaze to communicate. And I could see the frustration because it was using the predictive text, but that wasn't what he wanted to say because he had some certain saved phrases on his board. And I didn't want to assert myself because I also didn't know what he wanted to say. There were a few different words it could have been or phrases. So, how do you, either as the researchers or the clinic team, help to navigate those frustrations with those processes?
Yeah, that is frustrating. I wouldn't talk to a senator the way I talk to anyone else either. So I can see where that comes from. That maybe you would talk differently in certain situations, and maybe that's something that has to be incorporated into the design of these devices. Again, that's just another way that you can configure the device. But other than that, don't have a great answer for how we can. It's always going to be a trade-off for how much user control there is and how much AI control there is. And hopefully the user finds a good balance of those two in a way that works for them in most situations.
So this is another philosophical question. Maybe you can't answer it, but it's making me think of it. We're also in Harrisburg. My friend Steven gave some speeches about his experience with ALS, and he uses a device to communicate because he can't speak anymore. How much will you know that it's that person's voice, not speaking voice, but him or her, instead of something that's just AI? How do you know, as a caregiver, this is their intention? Do you have like some training with your clinic staff? Do you think about that kind of talk about making sure you're maintaining that human aspect as opposed to maybe it's all just a computer?
I think when we counsel people on their voice, when we hear those first bits of dysphonia where we know that these symptoms are really going to start picking up speed, we often talk about ways to preserve it, recording messages, we fairly frequently, like, you can get those cards that you can record messages that are teddy bears or things like that for people that you want them to have your voice. And there's also voice banking to have your AAC, your speech generating device, in your own voice. And there's also some AI that'll do it now too from snippets.
Yes,
Um,
really cool stuff.
but it's cool. But I think the question that you're asking, if I'm correct, is how do you hear and like how do you hear their speech patterns? Like how because I think everyone, you can tell they're, even in writing, you can tell what someone is trying to say and their habits and tendencies.
I interpreted it slightly differently. I thought you were asking about hallucinations. We hear a lot about with AI. Like, how do you know that you're not hearing just the garbage that the AI is spitting out and not actually what the person is producing. I mean, how do we
Both of those questions.
Yeah.
I think
Okay.
both of you have a good perspective on it.
And I think that we just counsel people that, it's this writing is still you, this is still you communicating. And granted, some people with ALS do have difficulty with language processing in addition to the motor side. But if they are still generating their own speech, whether it's through a machine or through themselves, it's still their intention that's very clear. And I think kind of like, you can always tell when it's your kid crying on like at the grocery store, like 2 aisles down, you can tell when it's your loved one still. So I think that the content of speech doesn't change, even if the way that we convey it does. And being able to tell that to someone to reassure them that, yes, this is still you. It's just a different way of communicating, and it sucks, but this is what not the tool, but just this whole thing. It's one more tool in your tool shed. It's one more weapon in your arsenal to try and overcome this.
I
Yeah.
was.
I was
Oh,
not
go
saying
ahead.
it super well.
Go ahead, Dr. Geronimo.
Because one of the hot topics in AI is this aspect of hallucination, right? If you ask someone what they want for dinner and it gives you an answer, how do you know that that's actually what they're saying if there's an AI in the loop? An AI has been trained on billions of phrases that say people mostly want pizza when someone asks them what they want for dinner. So these BCIs, they go through a large, or at least they currently do, and I hope they continue to, they go through a long period of validation where you're clearly getting answers from the person and not the assistive tool like an AI that's incorporated into it. So there'll always be kind of a safeguard against that. People should be using these AI completions or AI sentence prediction as something that can help them. But the main aspect of control is always with the user. And I hope that kind of gives you an idea. This is a good question that, researchers have to keep thinking about, though, because we want to make sure, even though it may be communicating faster, we want to make sure it's this person and it's their voice.
Yeah, I can ask you 10 hours of questions, so be careful with me because I have so many things I could talk about on this stuff. It does remind me with talking with some other researchers, they mentioned biomarkers to manage the success of studies and seen other ways to know that a drug is working or some other therapy. When it comes to working on BCI and understanding the neurons and the electrical impulses, do you have ways of testing like a different kind of biomarker where okay, this is working or this process is effective and we should move in that direction?
I can't speak to the BCI biomarker. I don't think it's been utilized in that way, but people have certainly looked at brain-based biomarker, ones that are either measured through imaging or electrophysiology or samples that they're taking, like from cerebral spinal fluid. Yeah, there's different biomarkers that use both the electrical activity of the brain, the structure of the brain from an MRI scan, or different types of fluid biomarkers you can get. I don't know if you have anything to add to that.
So, really, Dr. Grogan for this one, but you guys can both answer. One thing I remember from my first time being here at ALS United Mid Atlantic was being with a patient and they were learning about getting a peg tube. And the doctor was saying, you should consider this now while it's safe and you can learn what the process is, as opposed to later. And it's not as invasive as you think. So, early intervention is very important with this kind of basic thing like a peg tube. How important is early intervention with BCI? Because if you have someone who is going to continue the progression of ALS, it may lead to them not being able to communicate and speak. Is it better to have those conversations with you now so that they can get into using the technology as an early time? Their caregiver can understand how they're communicating. How early would you want to intervene and introduce those topics to them?
And I'm going to sidestep that a little bit, and not so much BCI, but other forms of communication interactions, like these
Mm-hmm.
AACs, these alternative and augmentative communication devices.
Mm-hmm.
So, including things like eye gaze devices, text to speech, things like that. We encourage them to try it early. If they have signs that they're going to lose the ability to communicate or have impairment early on, they may say, well, I can still talk with some impairment. So why do I need to do that? And I'm like, well, you should get used to it now. You should have practice now. You should be able to use it successfully before you need it rather than being forced into it with no practice. And at least for a training period, you're going to have a much harder time trying to convey your needs. So I think BCI is a little bit different because it's not really that widely used yet, and there's a bigger upfront cost. in terms of both financial, but also the intensive and invasiveness of it. Any kind of BCI is going to be an invasive procedure, no matter how minimally invasive. But for other communication tools, getting used to early on does make sense as far as a cost benefit type ratio.
I totally agree. No additional comments on talking about and reassessing AAC use often with your therapist and physician. But I will say my answer in regards to BCI would have been different again 5 years ago than it is today, where I've recently seen results where people who are unable to communicate are learning to communicate through a speech prosthesis or a speech BCI the same day. And this is specifically work done by the Brain Gate group at Brown University and Harvard Medical School, who've been showing some of these really interesting results. And I think they're well known by the ALS community, the research community at least now. But they've shown recently some really great results without lots of training involved. But that being said, I still agree with Dr. Grogan that these are things that should be discussed early on. Because it's not like you're going to jump from being able to speak to using a BCI. You're going to use an eye gaze system first until something radical changes and maybe everyone gets a BCI.
You mentioned augmented reality, and it makes me think of video games like Fortnite and Minecraft and all sorts of things. I have two kids, and they are playing Minecraft all of the time, unless they're sleeping or at school. And even at school, they might be thinking about
When you're
Minecraft.
talking about Minecraft, right?
So, like, do you see this technology for someone who is not able to use their hands anymore, not able to speak? They could exist in a virtual world like Minecraft or like Fortnite or other video games, and maybe they're not playing the game so much, but someone who has lost their ability to live their regular life before ALS in the real world, but they could live in a virtual world and enjoy that in a different way that maybe they couldn't 10 years ago?
I think this is a whole philosophical can of worms that we may want to address a different day.
Let's do it now.
So, all right.
Let's solve all the problems today.
Well, no, I think this generates so many questions,
It
but
does. Or all of the depictions of this in literature and media are bad.
dystopian. It does not go
So
well. For this though, there's even some research into this, not in ALS, but in other paralytic disorders, where there is some escapism in that. But how do you stay grounded in reality? And that's really, with virtual reality, you're in this virtual world. You have an avatar that's you in some way versus augmented reality, which is more, you see the things around you, but it's either things are highlighted or there's stuff running around. It's more the real world or extended reality where it's like you can see your computer screen in front of you. So it's more grounded in reality. So for the VR side of things, I think absolutely. And engagement input's going to be a little bit more challenging, although there are some really cool cases of people playing fairly difficult games with extreme disability using different types of switches and inputs. And they're not the fastest players, but they're able to complete pretty challenging objectives with very unorthodox and very creative ways to tackle it. So I think that is going to get better as we get better at these output type things with BCI and other invention. As far as the augmented reality side, I think it really does make a nice halfway house between it, where you can have better engagement with the digital world while still being grounded with the people around you. So you can still look at your kids, your spouse, your friends, your loved one, and not being completely encapsulated and blocked away, which I think is helpful in some ways. And there even was that paper on was it identification with the virtual self or something like that. And basically, how do you view yourself in your body versus view yourself in this virtual body? And are there feelings of liberation, confinement? How does that change how you perceive your situation? I think it's still such a young, fresh area of research that we need to learn more on how that would be seen on a bigger scale and in people with ALS or other neurological disorders or just the general population. So I think that that's where we get into like, is this going to be, this dystopian future where we're all in our headsets and not talking to each other and there's a population crash? I don't know. But that's, I think that's why we have to be careful in how we pursue it, knowing that it's this incredible tool, but we need to be measured in what we do with it, having seen even just what social media has done, even without being completely ensconced in it.
How that's rewired people's brains compared to the age before social media. You can only imagine it's going to be 10 times that at least when someone is living in a virtual world 24 hours a day.
And is my daughter going to say to my hopefully someday grandkids, like, oh, these darn kids with their virtual reality, why we only had social media and we were fine. While we're saying, oh gosh, these kids in their social media, like our world is doomed. So I don't know.
It's a little bit of both, right? You could think we always think of the or I do. I always think of the potential bad things that could arise from this, but these types of virtual worlds could potentially be or applications that allow a virtual extension of your body could be life changing for people, but it needs to be approached with sufficient regulation, in my opinion. I know that's not a great word for everyone, but you can imagine
Fine
if
with it.
you can imagine if your body was exposed, your body yourself was exposed to ads all the time, you'd be kind of a miserable existence. So these things would apply in the virtual world, and we'd have to take them into account.
I guess it could be
Well,
a
I
pretty,
know. Go ahead.
I was going to
I'm
say, it
sorry, I
could
didn't
be a
interrupt.
pretty big equalizer in a lot of ways, though.
And that's an important equalizer because there's always stigma against people with disabilities. And we've done so much to try and fix that. Because if you make a more accessible world, it doesn't make it a more accessible world for a person with disabilities. It's accessible for everybody. So equalizing that humanizes everybody. Where someone like a kid might feel uncomfortable talking to someone in a wheelchair, and now they can communicate as if they're not, there's no difference between them in terms of their abilities, and that's something that's really amazing. Not to get too off topic, but you talked about liking science fiction, how that kind of got you interested in the technology. The Switch 2 is coming out. We have a lot of other video games like the Xbox Connect years ago and some other things. Do you ever see things from the video game world and other technologies that are out there beyond healthcare and think, okay, how could that be reapplied to communication with ALS or other diseases?
Anybody even get a Switch 2 now?
I don't think
I,
they're. Yeah, well, we're hooked into this as well. We're video
Yeah,
game
that could be a
fans.
business expense, is getting a
Yeah,
Switch 2.
well,
I,
yeah.
not at the stealth prices, but the, we see some of it, as far as Switch controls, I think being the big one, like, and I forget what company was doing it, but they had like a fairly elaborate Switch control system to help people with different levels of ability interact with these games. And from the hardware level, I think we see some of that, and I'm trying to get some inspirations for the use of one of our current projects, or even using like a game controller to help control some of these devices. Like that actually, that already does exist, using like a PlayStation controller or
Hmm.
Xbox controller. But as far as like I guess is your question more about the cultural side of the gaming
When
world
you
or software
see,
side?
if you see that video games can be a test market for other BCI and brain technology, because you can see that these people who don't have a neurodegenerative disease, they are testing that this kind of technology works for playing a video game. They can, it could be something simple like Fruit Ninja, where they were swiping with their hand and they're not using a wired controller, and you can see how that works. But you can broaden that out and say, oh, if it works for that with kids and young people, maybe that same idea can work with other kinds of communication with your brain computer interface.
In technology training, we sometimes talk about gamification of our training protocols, making them more digestible for people to do. So it's not too far, I guess, removed to think that in the future, if you're training someone to use their BCI to control a robotic assistant, right? Someone who's going to go around the house and clean the dishes and wash the clothes. You could have them playing a game of Minecraft to train this sort of system to be able to do that, where you're controlling a virtual avatar to do different bodily actions. So I think these games that we play currently could be definitely incorporated into the training aspect of using a brain-computer interface. Whereas right now, some of the training protocols that we do have, people asking you to, okay, now imagine moving your arm, or now imagine moving your foot. Whereas if we could automate this process using playing a game and just learning the brain signals and how they interact with the world, using it that way instead.
Well, I find what you're doing incredibly fascinating and hopeful. It's exciting because you can see it working. It's not like a drug, which is important, waiting months to see if the biomarkers have shown progress. You can see right there in the lab that this is working out, or we need to make these changes to it. So, for anyone who's interested now, why should they participate in your trials? And how can they do it? So, and what are the things you're working on today that people should contact you to be involved in? So, why should they be involved, and what should they be involved with you?
Sure. So I think for any trial, there's always the selfless aspect where you're contributing to knowledge to help other people, help our understanding of the disease and how we can better treat it, either with interventions that modify the disease progress or improve quality of life. And then there's the selfish portion where maybe you can benefit from it directly. That applies to drug trials, observational trials, etc. In the case of our studies, it's a chance to get a peek behind the curtain and see, does this technology work? And then am I going to pilot it in my home or in the lab? So for one of our trials, we're looking at the Vision Pro. It's an augmented reality headset, uses spatial computing to basically float your computer around you. And we've had enrollment already where we're having patients do writing exercises, eye tracking exercises, and also just play around with it. Do they enjoy it? Do they think it's dorky? Do they think it's cool? Is it too heavy? Is it light? And basically, what are your opinions and how feasible is it to use this? And if people wanted to be involved, we have inclusion and exclusion criteria.
Yeah, we're accepting people who currently use augmentative communication devices. So people who use eye trackers, for example, but it doesn't have to be an eye tracker. So we're interested to get those people's opinions about how this device could work for them as a communication tool.
And it's just one for this study. It's a one-time trip to the sweetest place on earth, Hershey, Pennsylvania. And it's nice because it's a low commitment study. It's probably 1 to 2 hours, and you get to try something cool. And so far, the subjects have really enjoyed it. Like, they're asking to be part of a follow-up study to use it in their homes too. And I feel like if universally people are already saying that, that's hopefully pretty good news.
Yeah, totally agree.
It's really exciting. I'll put the information in our comments and the description on our website and in this video. So again, if you're interested in learning more about this research project and other ALS research, please visit our website, alsmidatlantic.org. And then I'll put the link here on our description for the work that Dr. Geronimo and Dr. Grogan are doing to support people with ALS at Penn State Health Hershey Medical Center. It's not just people who live in the area. Like they said, they've been talking to people in states all around our area who come to them because of the great reputation that Dr. Simmons has established there for 30 years now. Thank you so much. Again, if you're listening, please subscribe, follow, comment, like, share, so we can create some more ALS awareness. And Dr. Geronimo and Dr. Grogan, I look forward to all the work we'll do together in the next few years.
Johnny?
Pleasure.